I'm going to start recording and then share my screen. Say yes if you can see the screen. If you cannot, say no in the chat. So today is the last lesson before the summer break. Right, so I know it's like it's May right now and most schools are on summer break. So today is going to be the last lesson before summer break and it's going to be quite an important one, so make sure you pay attention. So if you can see my screen, say yes in the chat. If you cannot, say no. All right, yes. Okay, very good. Let's continue. So today you're going to be doing something with the rational root theorem. So this is the third lesson of our unit on polynomials. And today's the third and final lesson. Next, we will go over rational functions and graphing polynomials in unit 5, but that is after summer break. So summer break is going to be from June to July, and this class will run again once school starts. So you can enjoy your 2 months of break. Just make sure if you forget something, review it because we will be using it later on. So let's just go ahead and start. So let me just review the homework. So first, we need to find a polynomial with a leading coefficient of 6 and has the following roots: 7 with a multiplicity of 3, 2 with a multiplicity of 2, 3 minus 5i, and 3 plus 5i. So I'm going to give you guys 1 minute to just put your answers down in the chat. Of course, this is one of those where there can be a lot of different answers, right? It's quite open-ended. So even if your answer doesn't match somebody else's, it can still be correct. Okay, so I'm just going to give you a couple moments to do that. All right, so who wants to, okay, so homework over summer break. Yeah, great question. I don't think you can really call it homework over summer break. We're going to have homework, of course, for this specific class, but not like a homework packet over summer break. Just make sure you review your stuff and you'll be fine. There's not much really homework over the break. So who wants to volunteer to solve this problem? Are there any volunteers to help me solve this problem? It's not that hard. Should be pretty self-explanatory. Okay, any volunteers? How about William? William, would you like to do this?
Sure.
Right, okay. So how would you solve this? Find a polynomial. It could be, and it's really open-ended, really. A polynomial with a leading coefficient of 6. William, what is a leading coefficient? If you write a polynomial as a factor of a to the x minus r times x to the minus r2, so on, so on, so on. A is the leading coefficient. So what do we have?
We could have 2
6 times a product of linear factors.
2 Oh. Oh wait.
So the following root 7, if you write it as a linear factor, what is that going to look like?
Wait.
It is x minus 7, right?
Oh wait. Yeah.
What is the root? It's when x is equal to that number, then this polynomial equals 0, right? So it's x minus 7. What is multiplicity? How would you do multiplicity?
The exponent. X minus 7 to the power 3.
All right, and next?
2 x minus 2 to the power 2 and
Remember,
x
linear factors is x minus r, where r is the root. So if this is the root, what is it? X minus?
x minus 3 minus 5i, and the other one is x minus 3 plus 5i.
Right, very good. Okay, so that is all for this for this problem. Let's do the next one. I'm gonna give you like, let's say 2 minutes to do this one, if you haven't already, and then we can start. All right, so let's do this one. Write f of x as a product of linear factors. If f of x is equal to x cubed plus 9x squared plus 24x plus 16, if negative 1 is a 0. So let's find someone else to do this. Edward, would you like to do this?
Okay.
So how would you do this?
So first, I'd find the root So the root is 1 because x minus 1. So the root is 1, and then we
Are
can
you
use
sure
synthetic.
about that? I mean, it gives you -1 is the root. Negative. It's -1, right? So if it gives you -1 is a 0, the root is -1. It's not +1. You understand?
Oh, yeah, yeah.
All right, great. Okay, continue.
So we use synthetic division. Um, and that's 1, 9, 24, and then 16. Bring the 1 down, and then you get -1, and then you get 8, and then -8, and then 16, and then -16, and then the remainder is 0.
All right, very good. So we know that -1 is a 0. So what is the factor of, if you write the root of -1 as a linear factor, what is it? It's x plus or minus something, right? X, what is it? It's x minus -1, so it's +1. And we know what is remaining, right? Edward, what is remaining?
Um, Nothing.
Right, the remainder is nothing, but what about this? What is this?
Oh, x squared uh, plus 16.
Right, but we do need this as a product of linear factors. So how do we factor this?
X plus 4 squared.
No, it's not x plus 4 squared. So Edward, x plus 4 squared is equal to x squared plus 8x plus 16, where the 8x is gone in this situation, so it's not. Whenever you see something like this, difference of squares you can factor, right? But not
Isn't it
sum
8x?
of squares.
Isn't it
Yes,
8x?
right? What is,
It says 1, 8, 16.
huh? Every time my handwriting is so bad. Okay, thank you. It is. I thought it was like an imaginary number for a second. This is an 8. It's kind of that's kind of disappointing. All right. Thank you very much. Now, how would we factor this then?
Um, X plus 4 squared.
Very good. Okay. So this one doesn't have any imaginary numbers. Next, we can go on to the number 3. I think this one, yeah, this one has an imaginary number. Okay, I'm going to give you 2 minutes for this one as well. Yeah, sorry about that, Edward. Couldn't read my own handwriting. All right, let's continue with this one. So this one has a subtle point that you must understand, which is 4i is a 0. Who can tell me what is another 0 if 4i is 0? This is is part of the conjugate pair theorem we learned last time. So who remembers? If 4i is a 0, what must also be a 0? Who can tell me in the chat? If 4i is a 0, what is also a 0? Negative 4i. Very good. Very good, Edward. So you remembered this is the conjugate pair, pair theorem, which states if 4i is a 0, negative 4i is also 0. Okay, so let's just do this with synthetic division, Edward, I'm going to have you help me again on synthetic division. You did very well last time. So let's just continue with you. Okay, how do I do this?
You put 1, 2, 16, and 32. Bring the 1 down. Um,
I mean, you do it the same way, don't you?
4i.
Right. 4i, and then this is 2 plus 4i. Okay, can you now proceed?
And then, um,
All right. This is one of the ones where it's kind of annoying. So let's just do it on the side. So 4i times 2 is what? It's 8i, right?
yeah,
And what is I technically? The square root of -1. So what is I squared?
-1.
This is 16i squared, which is minus 16. Is that correct? Right. Okay. This is minus 16 plus 8i. And then what is that equal to?
Just 8i.
And what is 4i times 8i?
-32.
Very good. So then we are perfectly left with a 0. So we know it works. Right. So let's do this portion again because, well, not again. We know that negative 4i is also 0. So we can just do negative 4i, right? So how do I do this? Bring the 1 down, right? Okay.
Yeah. So that's -4i.
Right. So we are left with 2 and obviously negative 8i plus positive 8i is 0. So we are left with this very nice little factoring thing. Okay, so you're left with x plus 2. So we know -2 is also um a factor, right? Okay, so then we have x minus 4i and x plus 4i. Very good, very good. Okay, that's all for the homework. Hopefully it wasn't too difficult, but just use synthetic division, brute force your way through it using synthetic division. Synthetic division is always the way to go. It's very good. Okay, let's review the fundamental theorem and then we can go into the main topic for today, which really won't be too long, but it is super important. It's more important than many of the other theorems we have learned before. So this is very important. The rational roots theorem. Okay, but another important theorem that we learned is the fundamental theorem, which states that, okay, every polynomial of degree n is greater than 0 can be expressed as a product of n linear factors. All right, note These might not be distinct, hence the multiplicity. Right, we might have like x plus 1 squared times x minus 2 cubed. Yes, this is x minus 2 times x minus 2 times x minus 2, which is n linear factors, but it can be combined. So they might not be distinct. So note, right? But anyways, every polynomial, okay, let me add another one, of real coefficients. Now, if they are fake coefficients, like imaginary, 4ix squared, yeah, no. Okay, of real coefficients, every p of x of degree n greater than 0 can be expressed as a product of n linear factors. Okay, and we also learned that linear factors looks something like this, right? A, p of x can be expressed as a to the x. A is always it is the leading coefficient, which is always a constant, right? And this can be expressed as a times x minus r1 to the m1 x minus r2 to the m2 all the way to x minus rn to the mn. Right. So that is the linear factors, right? You can always write the polynomial as a product of linear factors, and remember, m is multiplicity. Multiplicity is the power of the root, right? So the power of the root. And we also discussed the effect of multiplicity on a graph. All right, so if you have an even multiplicity, let's say you have an even multiplicity, okay? What do you think would happen? So who can answer this? If you have an even multiplicity at your root, what happens to the graph? Right, so somebody answer this in the chat so we can keep this class moving on, right? What happens to the graph? All right, William, do you have an answer?
Both of the arrows go either up or down.
Right. So as you said, the arrows go up or down. What does this actually mean? That means that p of x has a turning point at r. This means that p of x has a turning point. Very good. And that is something like this, something like a parabola. You see, has an even multiplicity, negative parabola like this. All right, William, what about an odd multiplicity?
So one arrow goes up, one arrow goes down.
Right, so basically all this is saying is that p of x changes sign. Because, a root is basically just an x-intercept. It either, when the graph hits the x-intercept, it either bounces back up or it cuts through the axis and it changes sign into the negatives. So this is some variant of x to the third. It's some variant, right? Which has an odd multiplicity. This means that p of x changes sign. Right. Are there any questions on this? Any questions? If there are no questions, then I'm going to continue. Okay, so conjugate pairs. This was quite important earlier when we did the homework. Okay, and this says if a plus bi is a root, a minus bi is also a root. if a plus square root of b or nth root of b is a root, a minus nth root of b is also a root. So this applies to irrational numbers like such and complex numbers like such. Right. So if you're given, let's say a problem gives you, okay, 3 minus 5i is a root, then 3 plus 5i is also a root, then you can solve. Let's say it gives you, okay, square root of 3 is a root. Well, minus square root of 3 is also a root, right? So it's quite useful. All of these irrational and imaginary zeros always occur in pairs. You'll never find them in odd numbers mostly, so always in even numbers. So once you come across one, you always know that there's another, right? Okay, so now we can go to the rational roots theorem. So I'm just going to go over the rational roots theorem right now. State it. So make sure you have this in your notes. This is extremely important. And this will allow you this. I chose to end the unit with this is because this theorem allows you to factor almost every polynomial, right? Okay, so the theorem is as follows. The 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 only possible rational roots of p of x are in the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. That is the rational roots theorem. So I'm going to give everybody a chance to write that down in whatever paper or notebook that you have. So the only possible rational roots of p of x are in the form p over q, where p is the a factor of the constant and q is a factor of the leading coefficient. So make sure you got this down. So what does that actually mean? Let's say I give you 2x squared plus 3x plus 8. The only possible roots are p over q, where p are the factors of 8 and q is the factors of 2, right? So always remember, the factors of the constant are on top, the factors of a leading coefficient are on the bottom. P, right, is constant. Q is the leading coefficient. So now that we know that, what is P? It is the factors of 8. So what is that? It is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Those are the factors of 8. And we have plus or minus 1 and plus or minus 2 for Q. Then once you take P over Q, then you can find all of the possible rational roots. Does everybody get this theorem? Are there any questions on this theorem? Right. Okay. So let's continue with a couple of examples. So we're going to split this next problem into a couple of steps. So step number 1 is find the possible roots. Step number 2 is to factor and to find the actual roots. So first, let's find all the possible roots using that theorem that we just had. So who can help me on this? How about Jenny? Jenny, would you like to help? Oh, okay, William. All right, William. How do I find the all the possible roots of p of x here?
So we
So
first find
hold on. First, just tell me what is p. What is all the values of p?
it's the factors of the constant
Which is
10.
-10, but that
I mean
doesn't
negative
really
10.
matter. It doesn't really matter. So plus or minus 1 and go on.
Plus or minus 2, 5, and 10.
Right. So remember, you must have the plus or minus because 10 can be -2 times -5. Right. So it can always have the plus or minus because then you might miss a possible root. What about q?
The factors of the leading coefficient, they're plus or minus 1 and plus or minus 2.
Great. Very good. So then we can have p over q, which is all the possible roots, which is
1, -1, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 1/2, plus or minus 5/2, and that's it.
right. Very good. So let's see here. Which do you think would be the most possible here, William? What do you think is the most possible root that we can have?
Maybe 1.
Very good. So this is a very good theorem, but it doesn't just hand you whatever you need. It gives you all of these possible roots, and a lot of times you have to check them a lot. So how many? 1, 2, 3, 4, 5, 6. That's 6 roots, and then plus or minus, that's 12 roots. You have to check 12 roots through synthetic division every time. Obviously, we're not going to do that. You're going to have to be a little bit smart about it, right? And if you're going to be smart about it, first of all, just don't test the fractions. We don't even like fractions. And half of the time, it's not going to be fractions. So we can just cross that off. We won't check them first. 10, it's too big. 5, it's too big. It's probably 1 or 2. So let's just check plus 1. All right, William, I'm going to have you do the synthetic division for me. So for root 1, what is the synthetic division? How would you do this?
So we first put 2, 1, -11, and -10, and we bring down the 2. So, and then we put the 2 there, below the 1. And that will become 3, and we put a 3 below -11, which will become -8, and that will be -8, and it'll become -18.
So obviously that doesn't work. What about, let's try -1. Maybe -1 will work. Let's try -1.
That'll be 2, and then we have -2, and that'll be -1, and then that'll be 1, and then it will become -10, and it become 10, and then that's 0.
Very good. So -1 is a root. So we know that we have -1, so it's x plus 1 times what's left over?
2x squared minus x minus 10.
Very good. And this is just a quadratic. We know how to factor quadratics. How do you factor this?
So So the factors of 2 could be 2 and 1.
Great.
And the factors of negative 10 could be neg
Just say a random one. We'll test it out.
okay. Negative 1 and 10.
-1 and 10.
Yeah.
2 times -1 is -2 plus 10 does not work. We have to get it to add up to -1, which is -1x. So how about let's try 2 and 5? How about -2 and 5? -2 and 5, that's +1. So let's just switch the negative here. It is 2 and -5, so we get 2 times 2 minus 5, which is -1. So these are the correct factors. We get x plus 1 times x plus 2 and 2x minus 5. That is the solution. Do you have any
Oh.
questions?
No.
All right, very good, very good. So that is how you would factor to find these possible roots. Right, so I walked you through this first one. I'm going to give you, how about 5 minutes? So these can be quite long. And this one, there's a ton of roots. There's a ton of roots you can try in this one. No, actually there's not. Never mind. Yeah, there's only 4. Okay. Yeah, my bad. Anyways, I did not see that. It's 5/1. It's just 4 roots. Okay. Anyways, it is quite long though, since it's x to the 4. So I'm gonna give you a 5 minutes to try and do this, and then we can go back and walk you through it. Just make sure you use the rational root theorem. Remember P over Q. What is this? This is P. This is P. This is Q. Right? P over Q. List all the possible roots, and then try them out. But use common sense, because remember, the ones are the most likely. Don't go trying some fractions or anything. Just try the ones first. It's usually the ones. Okay. All right, let's go over this one. Okay, so who can tell me all the possible roots for this? All right, let's choose someone different. How about 0? Zebo, can you help?
I don't want to do it.
All right, that's fine. How about Sophia? Sophia, do you know how to do this?
Yeah, I can try to do it.
All right, that's great. What is P over Q? First of all, what is P? What can P be?
P can be plus or minus 5 or plus or minus 1,
And Q is?
plus or minus 1.
Great. So P over Q can be plus or minus 1 and plus or minus 5. See, only 4 roots. Okay. So what do you think we should try first? We should always
1.
try the ones, right? So how about positive 1? Let's try positive 1. Okay. So positive 1,
Yeah.
we do the synthetic division for that one. Okay. So let me just set it up. How do we do this?
You drop the 1 down, so that'd be 1. And then 1 there, negative 5, negative 5, 9, 9, negative 5, and then negative 5.
So you see, it divides perfectly. And so very good, very good. It divides perfectly. What if we do it again? If we do 1 again, I'm just going to do this one. So 1, 1, -4, -4, 5. But we still get the same thing. So great. It's a double root. We get x minus 1 squared times x minus 4x plus 5. X squared. Okay. So Sophia, can we factor this? Can we factor this?
I don't think so. Can we?
Right. We can factor it with, we cannot factor this with rational roots, but we could with imaginary numbers. So how would we actually factor this? We'd have to use imaginary numbers, and we set it to 0. So when we set this thing to 0, we get x is equal to the quadratic formula for this, which is 4 plus or minus the square root of 16 minus 20 over 2, which is 4 plus or minus 2i over 2, which is 2 plus or minus I. Then we get the following roots, 2 plus or minus I, right? So x minus 1 squared and x plus 2 plus I. Well, no, it's 2 minus 2 plus I times x minus 2 minus I, right? So those are the roots. So does everybody understand that? So-called this rational root theorem, P over Q. Make sure you don't forget it over summer break. Okay, that is all for today. Today's lesson was about a couple minutes short, but that's fine. It is summer break. So I hope everybody has a pretty good summer break, get some rest, whatever. Okay, and I'll see you in 2 months, actually. Okay, I'll see everybody then.
Bye. Bye.